possibilities to um, possibilities for discoveries to harvest energy from matter. As I said, for now we are stuck with chemical energy, and in numbers this means that 1 liter of fuel gives us about 9 kilowatt hours of energy, and in an average car, you're going to use about another 75. You're going to lose about another 75 percent of those 9 kilowatt hours, and you actually use about 35%, which isn't very much. So, because in this 1 liter of fuel there would be theoretically about 18 billion kilowatt hours of energy, as opposed to those 9 kilowatt hours we get by burning it. But again, we don't know how to extract all the energy. So, what are our possibilities to gain or to harvest energy today? Well, we have the harvesting of solar energy directly, for example by solar panels, or we can harvest gravitational energy with dams, or there would be tidal energy, or wind energy, or what we mostly do, burning stuff, chemical energy. And where exactly does this chemical energy come from? Well, it basically comes from transforming molecules. By burning fuel, for example, we transform those initial fuel molecules into carbon dioxide and water, and those latter molecules, they actually possess less energy than the initial fuel molecules. So this difference of energy is the amount of energy we gain. And because the matter involved actually loses some energy, the CO2 or the carbon dioxide and the water theoretically do also have less mass than the initial fuel, and that's actually true, but it's a very tiny amount of mass that gets lost in the process. And of course, there's also another form of harvesting energy, that would be atomic energy or nuclear fission. And with nuclear fission, you don't transform molecules, but you transform atoms. So in this case, you are splitting the cores of heavy atoms into lighter atoms. fuse them into one heavier atom. So for example, you take two hydrogen atoms and fuse them into one helium atom. And of course, because hydrogen doesn't contain any neutrons, you would have to take the heavier isotopes of hydrogen, which are called deuterium or tritium. So by fusing 1 kilogram of those hydrogen isotopes, you get about 992.5 grams of helium. So there's a total mass loss of 7.5 grams, which is quite significant. And this mass gets converted into energy, which is in this case about 190 million kilowatt hours of energy. That's about 7 times the energy you get from fission. So fusion would be about 7 times more efficient than fission, but still from 1 kilogram initial mass you only convert 7.5 grams into energy. There's still a lot potential to get more energy out of the mass. So how would you get all the energy out of matter? Well, the only way we know is by using antimatter. The problem is, it is too expensive to produce antimatter, and we don't know any natural sources for antimatter. So unfortunately, we can't use antimatter at the time to create energy. But what exactly is antimatter anyway? Well, I suppose you know how normal matter is built up, how the atoms are built up. Usually there's one or more protons in the core, joined by some neutrons and more or less circled by electrons. And the protons are positively charged and the neutrons are without any charge, and the electrons are negatively charged. Well, and in antimatter things are just the other way around. So proton would be negatively charged, which is then called a antiproton, and electrons would be positively charged, which are then called positrons, and the neutron stays neutral. So why is our universe made of matter instead of antimatter? Well, there's no final answer to this question, but it would be reasonable enough to assume that the universe might also, or might as well be created from antimatter instead of matter. But as far as we know, it isn't. So that's it about you basically created a particle, and that's called Hawking radiation, because Stephen Hawking was the first to describe this process. And actually, in the labs, they created photons the same way. And I don't know, but probably it might be possible to create other particles that way. So this might be an option to create matter from energy. Then there's one other idea, and it's called the Bright-Wheeler process, because it was proposed by two physicists called Bright and Wheeler, and they are proposing that the collision of photons, which means collision of light particles, the collision may create electrons and positrons, and this